Okay, today we are going to be looking at the specific heat of a metal lab. One of the first things we should make note of is that we're dealing with one equation. Heat in equals heat out, heat gained equals heat lost, Q equals Q, whatever you want to call it. MC delta T equals MC delta T. So these are the same equations we've been working on basically this entire unit. That is not going to change for this lab. We're going to use this lab to take a hot metal, put it in cold water, collect some data. We're going to know a lot of information about the water, and we're going to need to find the specific heat of the metal, okay, which we're going to be able to do after we work ourselves through this lab. We are going to have to set up a data table for this lab. There's going to be two main sets of data. There's going to be data for the water, and there's going to be data for the metal. So we're going to set up a data table that has the same information, just kind of two-sided. Again, we've been doing this plenty throughout the unit. Mass, specific heat capacity, which is C, temperature final, temperature initial. Notice we don't have Q because we're setting these equal to each other, so we don't need that. And we're just going to set up the data table. We're going to run the lab. We're going to collect some data. We'll then come back and we'll take a look at that data, analyze it, and move forward with our lab. One thing we could start off by saying is we do know that we're going to be using 100 milliliters of water, which is equal to 100 grams. We're going to make sure we measure that carefully so we can add that in right away to our data table. We also know the specific heat capacity of water is 1 calorie per gram degree Celsius, so we can put that in there. Everything else we're going to have to determine in the lab itself. All right, let's look at the setup for our specific heat of a metal lab. We've got pretty similar setup. We have a pan full of water. In that pan, there's some metal weights. That pan is hot. It's on a hot plate. We have our temperature probe. We have a scale. We have a brass weight just to show you what they look like outside of the water. Then we have a normal graduated cylinder. We have a styrofoam cup nested in a beaker. And now we can get to the procedure. First, what we're going to do, we'll get the mass of the weight. We got our scale. I know it's kind of difficult to see. It's 199.9. It fluctuated to 2, so I think we're probably just going to call it 200 flat out. Now I'm going to measure out 100 milliliters of cold water. Add that to my styrofoam cup. Okay, so we have our initial temp of our metals, 98.3, and then we're going to add in those metals to our cold water. We can get our cold water initial temperature, which is going to be, already tested it, we'll just double check it, 22.3. I'll take the metal out, 22.2. Take the metal out, I'll put it directly in. I'll let that heat transfer from the metal to the water. Once that temperature stops rising, we'll know that all the heat has been transferred. Sometimes it takes a little bit of time. Once the temperature finally stops, we can come to a determination that the final temperature of the water and the metal is 34 degrees Celsius. All right, so now we have a little math to do. Let's go through the data we have. We have that we had 100 grams of water. Water specific heat is 1 calorie per gram degree Celsius. The final temperature of the water and of the metal were 34 degrees Celsius, and the initial temperature of the water is 22.2 degrees. Metal had an initial mass of 200 grams. We are solving for the specific heat capacity of the metal and has an initial temperature of 98.5. Again, these are the two equations that we're dealing with. We have to use this equation. I mean, you technically could use the top one and run it twice. We're not going to get into that right now, but we're going to use the bottom equation. There's 8 total variables. We have 7, and we're solving for the 8th, so let's go ahead and do that. So I'm going to plug in the information that I know. I know that I have 100 grams of water, specific heat of 1, final temperature, initial temperature. Set that equal to the whole negative side of 200 grams of metal We're solving for the C of metal, and 34 minus 98.5. Now I can do some math. So let's start by focusing on one side of the equation at a time. 34 minus 22.2 is 11.8. And then 100 times that times 11.8 is going to give me 1,180. And that's all that I can do with that side of the equation. I flip over to this side of the equation. 34, do what's in the parentheses first. It's going to give me negative 64.5. Multiply that by, so I'm going to do 200 times C times what's in the parentheses. So this will give me negative 12,900. And then I can distribute that negative, which makes it a positive 12,900. I can kind of zoom that out. So here are the two sides of the, oh, I lost my C, sorry guys. This will be C, this will be C, this will be equal to each other. I got to get rid of that, so 1,180 divided by 12,900 gives me 0.091 calories per gram degrees Celsius, and that is equal to my C. Now I can take that number, compare it against known specific heat values, and I can determine what metal I actually